Okay, so let's get started. So today we're going to be learning about linear regression, and specifically, we're going to actually implement our own linear regression algorithm in Python using a Google Colab notebook. And if you haven't never used Google Colab, don't worry, super simple to set up. And if you don't have Python in your machine, you don't need it when you're using Google Colab. So you have everything you need to do this. So to start, let's talk about a little more specifically, what does linear regression mean to you guys? I mean, what is this? What do you see from this chart? Can somebody unmute and just, talk?
It's like a line of best fit.
Mm-hmm. So we have a bunch of data, right? And it's like this is a scatter plot where we have each x corresponds to exactly one y, and you have a point, right? And now we have a bunch of these scattered points. And exactly like you said, Nina, the linear regression algorithm is one that plots a line of best fit that kind of tries to explain what the data is showing, right? Because if this red line wasn't there, like we'd be able to, we can, this one's pretty clear. We can identify that there's like an upward trend, right? But maybe this data sometimes, maybe there'll be it'd be a huge data set with like millions of points, or sometimes it may not be so clear what direction it's going in. And that's when having a line of best fit is really helpful. So what do we need to plot this line? We need two equations primarily. First of all, we need to calculate the slope. So this is a little bit different than what you probably saw in your algebra class for calculating slope, but the underlying idea is the same. We're just basically taking a mean sum of all the x coordinates, all the y coordinates. Don't worry about the math too much. We're going to code it, but I will guide you through it. It's more complicated. It's less complicated than it looks, I promise. And then the second equation on the bottom, that's to calculate our intercept, or bias is another word for it. And as you can see, I basically point out, it's basically y equals mx plus b. It's just rearranged, and we use c instead of b. This is a good image that I found online that kind of captured everything. These are the two equations we need to know. Do we have any questions so far? Can you give me like a thumbs up if we're good? Awesome. Okay. So that's about it. Let's code. So how do we set up Google Colab? Let's all open our drives, and I'm going to do this in the cohort 1 folder, but you should probably do this in your personal Google Drive. And I'm going to click New, and then under More, I already have the Google Colab added, but you might not. So I would click Connect More Apps, and then once this loads up, if I just search up Collaboratory, it's already installed for me, but you can install it to your drive. Click it, and then once it's all set up, you go back into New, and you just click a new notebook. Thumbs up again. Make it clear. Yep. How do you add it?
When I try to add it, when I try to, it says unavailable for install, whitelisted for install by admin.
Are you on a Google account that's like a part of a G Suite or something like that, or part of your school?
Yeah.
I would switch to one that's not part of your school. If you have a personal Gmail, I would use that.
Okay, give me a second then.
No worries, we can wait. And Megan, let me know. Give me like a thumbs up when you're on the notebook page. In the meantime, I guess I'm going to talk a little bit about what this is. So if you've never used Ipython Notebooks, welcome. This is basically a sort of environment where you can run code in little blocks at a time, in little chunks if you want to. So you can see here at the top, there are two types of cells. There's a code cell, and then there's a text cell. So right now there's a code cell, and I can type print, hello, and I just need to connect to Google servers. So because the reason Google Colab is really cool is because you're running this off of Google servers rather than your own computer, which is why Python and everything is kind of packaged and ready to go. So this is a code cell. If we run it, let me just click on it, I get a hello out. Or I can add a text block and, you know, same idea, hello. If I can just add a code block, you can see that that appeared. So this is Colab. Pretty simple to use. Just make sure to click connect. That's going to exist right here. And you can see here, it tells me that I'm connected to Google Compute Engine backend. So that's just a fancy way of saying I'm using Google's computers rather than my own. So let's get started with the actual project. You all are with me so far, right? And if you're not at any time, please unmute and interrupt. Since there's only 3 of you, I don't want to be checking the chat. Please just rudely interrupt me. It's fine. Let's start by importing the library that we're going to use. So we're going to want to import NumPy, and we're going to import it as NP just for brevity. And what NumPy does, it lets us create arrays that Python can manipulate super, super fast. So that's all it boils down to. So we're going to create 2 arrays where we store all of our x values and all of our y values. And so I'm going to create a new variable called x values, and it's going to be an np.array. So I'm calling my NumPy library and saying I want to create an array. And inside this array, I put a parentheses and a bracket, and let's put a bunch of numbers in here. So I'm going to try to put 10 numbers, all random. 2, 4, 4, 3, 5. Oh, that's actually 6, 9, 7, 3. How many more do I need? 1, 2, 3, 4, 5, 6, 7, 8. 2 more. 7, 1. And then I'm going to do the same thing for my y values. So we're just creating an array using NumPy with all of our x values and another one with all our y values. So these are just totally random things that I came up with. And you'll see later on that these are basically going to be our 2 points. So we have an ordered pair of 2, 6, another one with 4, 3, one with 4, 5, and you get the picture. All good? Okay, so now that we have our data, we kind of just created our data. If you wanted to extend this project a little further, you might find a data set from somewhere like Kaggle or data.world. But this is a super easy to create our own little data set without much effort. So the first thing we want to do is define our best fit line. So we're going to need if we remember the equations from earlier, we need to find our M, and I'm just going to call this B. So it's pretty simple to do. Let's pull up the formulas as they are on Enlight. I'm actually going to hop over to Enlight real quick. Actually, I think I have it open in a tab somewhere. I do. Let's just use this instead. So these are basically the 2 equations that we're programming, very simply, where the bar is the mean of everything in the x. So we're basically just running this. We're going to create a function that computes these 2 equations whenever we want. That's basically all it comes down to. And you can just follow along with me for the actual syntax. Let's go back to our notebook. So let's create a new function. So we start by saying def. Let's call it define best fit line, and it's going to take in our x values and our y values. Cool. And now let's define M. So M, we're going to follow the formula from here. Oh, I'm on the wrong tab. We're going to follow this formula, and you can just follow along with me. So I'm going to open up a bunch of parentheses. Don't worry, they'll have their use. So we're going to start by computing the x values, and we just take the mean of them by calling the function .mean, which is pretty nice and easy. And we want to multiply them by the y values .mean. And we use parentheses again to indicate that we're calling a function. Great. And then from that, let's take a look at what we do next. We want to subtract the mean of x and y together. So in order to do that, we're just going to say, let's open parentheses again, x values times the y values. Oops. And then whatever that result is, we're going to take the mean of it. So if you can see what's going on here, is that first we multiplied the mean of the x values by the mean of the y values, and then we multiplied all the x and y values together and took the mean of that. And this is just, we're just following along the formula that, you know, there's the ugly version here, and then there's a slightly prettier version right here. Great. So we did that. And now I'm going to just for enhanced readability, I'm going to put a break. When you put a backslash like that, you're just telling Python to go to the next line, basically, which is kind of helpful. And so let's see. Yeah, I'm going to open up new parentheses and say, let's say, we want to do what? What do we want to do now? This is important. We want to take the mean of the x values squared minus the squared mean of the x values. So you see that where the square is actually makes a pretty big difference. So we'll figure that out how to do this. So let's say x values dot mean, and then we want to take the square of that, and from there we will subtract. Let's open parentheses. We're going to take the x values and square them inside the parentheses and take the mean of that. I think I missed parentheses somewhere. I'm not completely sure. Yeah, I definitely did, because these guys need something to close them up. Aha. Are you all with me so far? We'll find out. I mean, we'll see if we got the equation right when we run this cell. So let's move on and let's do our b. Thankfully, our b is very simple. We're just going to take the y values dot mean, and I'll show you this. We're going to take the mean of the y values and subtract the m that we just calculated, the m times the mean of the x values. So let's go back to our project. Minus m times x, not z, x values dot mean. And finally, because all functions need a return statement, we're going to return m comma b, so that we return both of these two variables that we just calculated. And so now that we've returned them.
What do you mean by return?
Okay, yeah. So when you define a function in Python, there needs to be, you give it an input. So in this case, we're giving it an input of x values and y values, right? So think of it like a math function. You give it an input, you have to get an output. So return is how we tell the code that we want to return these values. We're going to put in this data, and we're going to get these two variables out. Does that make sense?
Okay. Yeah.
So you need a return statement in a Python function. That's just how it works. And you can think of it, when you think of Python functions, think of a math function, right? You put in an x and you get out a y. So in this case, you can imagine that these are our x's and these are our y's.
Gotcha. Okay.
So now that we did that, I'm going to make a new line. Actually, let's just run this code cell. Let's make sure it didn't break. So I'm going to click run. I think I got it, because it didn't, yeah. So I would run this now and let me know if you get an error.
I got an error.
I would just compare your code with mine and just count parenthesis by parenthesis and make sure that they match up exactly.
Okay.
Nina, how are you doing? Good? Okay. Srindy, how are you?
I think good.
Okay, sweet. So we'll give Megan a minute to catch up, and then we can keep on going. But
Sorry, I definitely missed something like really
yeah,
small.
no, it's always the little things like that. It's totally fine. I guess to give you all the roadmap of where the rest of this is going to go, we're going to calculate our regression line, which is we basically already did all the work. We kind of just have to format it. And then we're going to calculate, well, actually, let me rephrase that. We're going to pick a coordinate to predict now that we have our regression line, and we're going to calculate what the best fit line will be. And then finally, we're going to plot it so that we can see what it actually looks like graphically. And we can do this all with Python, which is pretty awesome. Actually, I can probably save you some time now that I'm thinking about it. Thought about it like a minute too late. I'm just going to drop this in the Zoom chat. That's probably the best way to do this.
So now when I hit run, it doesn't say syntax error anymore. It just doesn't say anything.
Okay, perfect. Then you're good. You see, mine didn't say anything either. So I guess I sent that in the a minute too late. So now the code ran.
Okay.
The fact it returned the value, but it didn't print the value because we didn't ask it to print it. So now we know that the value for m and b is stored inside these two things. So now we actually want to call the function, right? Because we only defined it. So let's set our m comma b output to be equal to this best fit line function where it takes in the x values as well as our y values. And then the shortcut to run the cell and create a new one right under it is shift enter. If we do that, you will get an answer. I mean, actually, you won't get an answer. You'll just get these two variables that are saved. So now, if you're all on the same page as me, we can print out our results. So let's do a print. And I'm going to do a formatted string because they're pretty. And you just put an F in front of your quotes to make a formatted string, and you'll see what the difference is in a sec. Let's say our regression line is going to be y equals, and then let's say m times x plus b. And what we did here is we put the m and b in curly brackets so that it interpolates m and b from this line. So what we're literally doing is inserting the variables into our string, which is pretty cool. Because we don't have to like concatenate them together or like make sure the type is correct or anything like that. We literally just insert them directly into our print statement by using a formatted string. So if we run this and we did it right, you get, this is my regression line. Yours is not going to look this way unless you use the exact same numbers as I did. How are we doing? Thumbs up, thumbs down, no thumbs. Okay, awesome. I'll give you guys another minute. And so now we have our own regression line, right? Mine is kind of wacky. It has a really tiny slope, but you know, it's the best fit for the data that I gave it. So now that we have our line, let's make a new code block, and let's predict a coordinate. So let's create a new variable, our x prediction, right? I want to know if I put in, I don't know, let's say 12. If I put in 12 for x, what is my y going to be? We can calculate this pretty easily, right? Let's create a new variable called y prediction that is equal to m times x prediction plus b. Y equals mx plus b, right? That's literally all that's going on here. And if we want to see that that coordinate, then what do? We just say we can print y prediction, and we should get not y values, y prediction. So when I put in 12, it gave me a prediction of 4. And looking at the numbers, that kind of makes sense. For me, anyway. For you, it'll be different. Sweet. So now what did we do? We created we have a predicted point from everything that was, that we gave it. We got our line. But what if we actually want to make a line that works for every single point? We're going to use something called a list comprehension, and don't worry about this syntax, but essentially what this is going to do is basically create a best fit line that uses all the points in our data. So I'm going to create this new variable called regression line, and it's going to be a list where we do, inside this list, we're going to do m times b, actually, excuse me, m times x, and then plus b for x in x values. So all this really does is it does y equals mx plus b for every single x in x values so that we can create our line. Because this was just a prediction, right? We didn't know what y would be, but we do know what the answer would be here. And to avoid just plotting them like this, we can create our line like this. We're going to put these on a scatter plot later, but we want a line to go through them, and that's what this regression line actually does for us. Is everybody still good? Awesome. Okay, so now we're going to move to the last part of this workshop. We're going to plot this thing. So this is going to be actually pretty fun. We're going to use a Python library called matplotlib, and we're just going to import it like this. We're going to say import matplotlib.pyplot as plt. Google gave me the suggestion to finish it. And so there's just some syntax to create a plot here. So let's say plt, whatever we want to call it. We're going to say plt. And we say plt.title. I'm going to call it Max's plot. You can call it whatever you like. Don't call it Max's plot because it's not mine. Great. And so now we have a plot that has we have the title of a plot. We don't actually have a plot yet. Let's make a scatter plot, right? That makes the most sense. If we think about this is a scatter plot with a line of best fit through it. So let's plot all of our x values first. So we're going to do plt.scatter, and we want to scatter the x values as our inputs and the y values as our outputs. And let's give it a color of let's find a nice like blue, I would say. Let's look up a hex color generator. Actually, hex color tool. That's easier. Okay. I'm just gonna pick a random color code. I want a nice blue. I like that one. That works for me. So I'm just gonna put that in. So we know we can control what color they are, and let's give them a data label as well. So we're gonna call it data. So make sure that you're separating your parameters in this function, your arguments, with a comma so that they don't get confused. And so if we plotted this as is, we should probably just see a scatter plot. Oh, there's nothing yet, actually. Okay, we got to keep going. That's fine. So what's next? The truth value of the array use that. Okay, we'll figure that out later. So now let's plot the predicted point, right? Because we have our data, but we also have this prediction that we made, and we want to plot that as well so that we can see how the line of best fit matches up. So let's do the same thing again. plt.scatter. This time we're going to do x prediction and y prediction. And let's give this a color of something red. Yeah, let's go with this red. And we're going to give this label a prediction. Let's call this prediction. Finally, let's plot our regression line. plt.plot. We're going to plot our x values because the y value will be the actual regression line. And the color of this, let's just make it black. So we're going to say, put 6 zeros in like that. And then this label will be the regression line. Finally, we can plot our legend because we gave all of our data. Oh, I know what I did. Sorry, guys. change these where I put data before, change that to label, because right now we want to put a legend, plt.legend, and we'll put location equals 4. That'll put it in the bottom right, and that's just a pleasant place to look at it. So once you guys have all of this, you can run this cell, and wow, I have a nasty plot, but hopefully yours looks a little bit better than mine. How did we do? Serindy's got one. Does it look better?
No, I used the same numbers as you.
Excellent. How about you, Nina?
I don't know what I did, but I don't have a line.
Oh, you don't have a line? So did you, when you did regression line, did you create this list comprehension?
Yeah.
Okay. And then you plotted it with the X values and regression line, right?
Yeah. Weird.
That is weird. Megan, how did you do it?
I'm still typing in the,
Oh, okay.
the last
All right.
couple lines.
Go for it. Yeah. I'm thinking, Nina, what could have happened?
I might have just like mistyped something at some point.
That's totally possible. Yeah. I'm wondering what it might have been. Because so you got the blue points and you got the red point, right?
No, I didn't
No?
get the red point. What did I do? That's really weird.
I'm definitely happy to look at this with you right now. I mean, this is the end of the workshop, right? What did we do? We kind of recapped what linear regression meant. We went over the equations for it, and we actually implemented it on our own in Python using a Google Colab notebook. So if you wanted to take this a step further, there are two immediate things that come to my mind. You could learn how to calculate the R² value, which is a metric that explains the variance of the data. It kind of explains how good is your regression line. And the formula to do this is actually on the Enlight tutorial, so you can take a look at that if you're interested. Or another thing you guys could do, like I mentioned at the start, you can pull a data set from like Kaggle or any other data repository, and I can give you guys suggestions if you're interested in doing that, and use those as your X and Y values and see what kind of line you get.
I figured it out, so.
Yay! So did you get something like a little bit better than mine?
I think I forgot a hashtag, so.
Oh, that would make sense. Okay.
Yeah.
Cool. But do you guys have any questions, or are you still trying to, Megan, did you get a graph as well?
Yeah, and it looks like yours because I used your data too.
Excellent. You'll have really terrible linear regression graphs. Maybe you can put in some data that might make a little more sense and see how the line changes. That might be fun.
Yeah.
Like if I were to throw in, I don't know, if I threw in like 15 here and then just ran all of these again. Let's see how it would change. It looks a little bit better now, but it's still not that great. But yeah, any questions?
So does this Google Collaborator, does it only like, is it only Python, or can you like use different languages?
That's a great question. I think we can check the runtime. I think it might be able to use Julia, but that's neither here nor there. Let's see. Change runtime type. No, I don't want this. That's literally what I just clicked.
So let's say we were to do this in terminal. How would you get that graph?
To be honest with you, if you ran this from terminal, you would want to run another command, and that would be plt.savefig, I think. Yeah. And then you'd say mygraph.png.
Okay.
And that would save it in the same directory as the Python file.
So you said plt.savefig?
Yeah, that should be it.
Okay.
And then just give it the name and give it a PNG file type. Those are nice and simple,
Okay.
easy to use.